Okay, I think we're live. Let's check on the classic live thing, and let me give it a quick listen to make sure the audio levels are right. It wants to. Okay, I think it's loud enough. But yeah, boom. Okay, so this stream is kind of it's a spiritual continuation of last stream. And here, let me get a little banner printing. Print. Welcome to the stream. 20 go to 10 run. Okay, so what we did last stream was I pretty much struggled the entire stream through through connecting to my Commodore 64 via the internal modem. Um, so here, let me do a diagram for y'all. Oh, there's the live stream thing. Excalidraw. Okay, so here's how it works. And here, let's get this. So I wrote out some programs before the stream just to make sure I understood what I was talking about this time, and just be a little maybe a little less disjointed. So here's how it works. So here, let's move this. Bam, bam. Okay, there we go. So okay, so here's how it goes. So all right, so my computer. So I've got this Python program. I got a Python program, and Python. What color is Python? Python's yellow, right? Light, whatever. That's good enough. I have a Python program. I connect to it over a socket, and then I'm able to use this socket to write data over the wire to the Commodore 64. How does the Commodore 64 connect to the internet? Well, use the modem, like a dial-up modem, I think is what you call it. And in fact, here's what it sounds like to dial. To dial into a Commodore 64. What's the name of the program I was working on? Control.py. Okay, import socket, establish connection, and then return. So we'll establish the connection, and you'll be able to hear what it sounds like. And I just to be sure, let's do some settings first. So on the hardware level, what we have is we have a modem that connection internal expansion RS232. So that's the user port. And on the Mister side of things, we got to make sure we have the modem is set up. The baud rate is 300. Actually, we're going to bump this up to 600 maybe. That'll only matter whenever we're writing the program. But let's just run the program, and you'll hear it. Oh, I turned it way down. You can't hear it anymore. All right, let's do that again. Okay, and I put that on low because we're going to be connecting and disconnecting a lot, and that's really annoying. So yeah, that's how the Commodore 64, what's called modem, works. So let's get to I keep pausing and umming. I'm texting on the side. I apologize. That's unprofessional of me, but I'm not a professional streamer, so big whoop. Um, okay, so let's get back to the diagram. Let me keep explaining, so I'm not. So the Python program, it connects via a socket, and this is over Wi-Fi. And, I'll label it. I'll say socket. and make it small. Ugh. Socket. This goes over Wi-Fi. Let's do white. Wi-Fi. That's large. This is a Wi-Fi connection to the Commodore 64 via the RS-232 port. RS-232 port. And there's secretly, so the RS-232 port is just a user port, right? Like you know what a Raspberry Pi is? So here, let's see a Raspberry Pi. So a Raspberry Pi is a little computer, like this whole board that you could literally fit in the palm of your hand. And in fact, there are some that are even smaller. Like here it is on a computer, on a table. But this little board right here, these pins up top. Let's see if I can zoom into that. Open image in new tab. Okay, so a Raspberry Pi is a little tiny credit card computer, credit card sized computer. It's a little computer, and these things on the top are what are called GPIO pins. I don't know what that stands for, but what I can tell you is that you can write a program to interact with other hardware using those pins. So you can send, basically, at the end of the day, you're sending little electrical signals and you're receiving little electrical signals that you can interpret as data in your code. And you can control other devices with it. You can control it. You can blink an LED is like the classic beginner project. Let's see if there's a diagram or a picture of someone using the GPIO pins. Raspberry Pi GPIO pins. So yes, this guy, he's got like a motor, a light, a speaker. I don't know. I think it's a speaker. I don't know. But yeah, you can use your GPIO pins, and yeah, you can control electronics with it. And actually, the serial port of the Commodore 64 is very much the same way. So you can control external hardware with that port, which is really, really cool. In this case, it's connected to a modem, and we're actually going to need a bigger box. Because remember, I've told you that I run this not on a Commodore 64, but on a Mister. So we can put a big box around here. We're going to put a big piece of text that says Mister. So it's like an emulator. You can think of like an emulator, right? It's another computer I have plugged into my monitor, right? That's what gets you this screen. And yeah, it has a Commodore 64. And actually in here, is a virtual modem. Virtual modem. So this is the full setup that I have going here, and I'll go ahead and restate it just in case my chunked up explanation wasn't clear. Group selection. Okay, so all right, so this is the theory. Okay, we have a Python program connected via a socket over Wi-Fi to the Commodore 64, and to get the Wi-Fi connection working, the Mister FPGA has a virtual modem, right? Because the Commodore 64 is running inside of a Mister. Got a virtual modem, and it's connected to the user port. And I can go ahead and open that as a file. So on this side, I can write out a little program that, like, just some pseudocode. Open RS, open user port, and then read bytes. And of course, once I have bytes on the computer, I can interpret those bytes as kind of whatever we want. So the plan for today, we're going to do baby steps. We're going to start off by getting data to the Commodore 64 and sending it back. And I told you that I had some pre-written programs that did that. But before that, I am going to BRB. I have to go pee really bad. I'm back. Let me make sure it's displaying properly. Yep. Okay. And let me listen. Perfect. Okay, so that's the setup. This is how we're gonna do it. Python to Mr. Virtual Modem to RS-232 port, which we can open it up as a file and like read from it. And in fact, let's just do a little basic example of that. Here, let me write this program out. So you know what? Oh man, this is gonna be a struggle because okay, on this web window, I have all these guides open. Um, I learned what this technique is called. It's like, oh god, I forgot what this technique is called. It's like keyboard. Ah man, one of the techniques that I'm gonna show the keyboard buffer code injection. Okay. Using load inside a basic program. Okay, yeah, this Reddit post describes. Nope, nope. Man, okay, wait. C64 keyboard. Is it this one? I swear on my life I read a program. I read a thing that had a program that basically let you write the keyboard buffer. Yeah, okay. Keyboard buffer. Enter commands programmatically. Yeah, this is that Stack Overflow answer. Maybe it was in this. Oh man. Manipulating the keyboard buffer? No, this is Commander 16. Okay. Um, Keyboard buffer code after program exit Commodore 64. Because at the end of the day, what we're trying to do is we're trying to get something uh, called an eval ready, where what we want to do is I want to be able to send basic code or some kind of basic code. We'll get to that in a minute. I want to be able to send basic code over the wire and execute it, and then go back to listening. That's the plan. Let's see if that's possible. Let's see that's possible. And this is one of the ways that I'm going to try and do it. Um, yeah. Okay, wait. This Gemini has an overview. Okay, yeah. So, all right, we do some of this in our program. Oh, here we are. But okay, let's move you over here. Let's do a basic program first, and I'll zoom in, try and make it a bit more legible. And in fact, I might even make you a little smaller and then make you a little bigger. Okay, so, all right, you're not gonna be able to read all the code perfectly, but should be a bit better. Let's move our little decal. Let's move our little decals around. Why is this locked? Sorry, I'm fiddling with OBS right now. Image, yeah. C64 logo. Boom. And yeah, connecting remotely to my computer is good enough. All right, let's edit control.py. So, and okay, low key, it's got to be a little smaller. So, sorry guys, I need something to work with here. I'll be explaining the code as I go. So if you don't even have to be watching, you know what I mean? Yeah. So we can send bytes over the wire with just socket.send, right? We can send it across to the Commodore 64. And yeah, so this takes this list of messages. So I have a list of messages that I've highlighted here. and then it sends a new line or a clear screen character. Then for every message, it encodes it properly, sends it across the wire, waits a little bit, and then sends a new line character for the next message. So this program plus, and I think we can split and then open ls, what was it called? Get prog basic, open get prog basic, get prog.basic, edit, get prog. Okay, there we go. So this is the program that we wrote last time. Okay, 10, close 1. So just to be safe, we close the device, open 1 to 0. This is just kind of the mode. And then it's telling us this chur6 is the baud rate. And then we set up a little buffer here, which I don't think I ever use this. I think this program kind of ballooned to the point of non-essentials as I was writing this. And miraculously, as I was first getting into this, I didn't even know what to look for. So I asked Google Gemini, I asked an LLM, I know, kill me. But unfortunately, it was a very easy way to find the information I needed. So we'll get a character from the device, store it in a string called $. And here, you know what? I realize how I can make it bigger is I can shave off a little bit of these borders. There we go. And then move it up. Okay, so that should be a bit more legible to you guys now that the code's a little better. And I'll edit the text. Connecting remotely. Connecting to C64 with Python. All right, here we go. We're gonna get an incoming byte, store it in $. And it'll get no matter what, even if there's nothing there. If it's empty, then just go to line 20 and just keep repeating. We'll print the character so that we're just echoing what we got with no line. And then if low-key, let's just do this. And then go to 20. So this should just print. This should just print no matter what. And yeah. All right. Right. Illegal device number error in 10. That is weird because it was working last time. So let's check the hardware settings. Hardware, external IEC, expansion, maybe it has to be VIC 1011, I don't remember, but it's set to RS-232, connection mode internal. Yeah, let's try VIC 1011 maybe, run. Illegal device number error in 10. Open 1, 2, 0, chur6, and that should actually be chur7. Because, and then B $ is equal to blank. Huh, which one does it not like? Can I close any arbitrary device? Exit X. Don't know what that was. I have a theory that I'm not on the right. Yep, it's almost definitely this. Sorry, I'm not on the right system ROM. System ROM standard. So, okay. I'll have to retype the little program, but it's 3 lines, so it should be easy. So, okay. 10, close the file, or open the user port. 0. Sure. Let's try 7. 20, get a byte. Oh, shoot. There we go. Get a byte from the device, which is device number 1. a dollar sign, and if a dollar sign. So if the byte, the string, is nothing, then just keep getting more. Otherwise, we want to print it out, and then go to line 20. So, okay, so right now it's in a mode where it's just accepting anything we'll give it. So here, let's go up here to this, and we'll say vsplit terminal python control.py. Okay, so I didn't change the program. Correct. Okay, so it does say it's connected. It says it's connected up there, right? Run ring connect no carrier, right? It drops. So let's get rid of this return, and then run it again. Okay, ringing, doing some white noise, and then yeah, boom. So the program that we wrote, it sends this hex 93, which is the command code for clearing the screen and moving the cursor to the top left, right? Because Petsky, which I have saved over here, I have the table somewhere. I'm not going to find the reference, whatever. Petsky is the Commodore 64's like text standard, and it has command codes for moving the cursor around the screen. Here, let's stop the program. So yeah, we can get bytes from the computer. We can do stuff with them. The plan is we want to get a program. Or here, let's do something first. Actually, let's see if we can send stuff back. So here, what about like what if we reserve a character or something like that and say like here is there any Petsky that's like reserved and not used? Control N, switch text to lowercase, move cursor down, turn reverse on, delete character. Okay, and then a bunch of characters, pound. Okay, and then some duplicates. Some ways to set text. Inverted equal sign, function keys, switch text to uppercase, clear, put space, duplicates. Okay, so I have an idea. What if we use one of these duplicate characters? Because here's the plan. Is we want some kind of data format because right now with our diagram, and let me move the management to that panel, move these docs over here, and I'll go to the explain scene so that my computer is full screen. With this, the way it works, let's focus on this part right here. Right, we're focusing right here right now. What we're trying to do is send data in a coherent way over the network. And we have the issue that what if we accidentally drop a byte? And how do I tell the computer like, hey, I'm ready for input versus hey, I'm not ready for input? That kind of thing. We have to manage that state between the two. And full disclaimer, I know nothing about network interchange formats. I know nothing about how that works. Like, on a modern computer. So I'm just gonna make something up, and I know I know I can get something working, but how good it will be is not exactly sure. Let's put it that way. And it looks like actually the mic is a little quiet. I'm a fool. So sorry. Okay, I turned it up a little bit to like 30. Okay, and it's touching the yellow now, and I want to do like dancing in the yellow. So if you're viewing and it got a little louder, that's my bad. But sorry. Oh, and I don't have chat open. I'll be right back, but let me grab chat. Okay, I'm back. I have my computer. I'm gonna get chat open. Live hub or live control plane or whatever. And there we go. Okay. Sorry about the noise. I have a chat window. Ta-da. Beautiful. Let's get moving. We have a Python script. We can send stuff over. I don't know how to receive bytes over a socket. I never worked with Python socket library. Um, sock Python sock dot receive buff size. Okay. Until data arrives or the connection closes. Partial returns. I don't know how. Man, I don't know what kind of socket this is. Oh, I'm not. Here we go. Sorry. I'm here. I'm not BRB'd. Um man. Okay. Well, let's list our program, and instead of that, let's say we want to, I mean, it was in the Commodore manual. Commodore 64 get keyboard input. Okay, yeah, so it's just get. Um, so we want to start off by getting some stuff and then go to 20. And then, so let's rename the variables. So we'll do get I $, and then if I $, that's input. And then we want to print it. But, and let's actually make this line 40. And then line 30, after we get a character, let's also get an input character. So we just get a keyboard character. If keyboard is empty, so if the keyboard is empty and the input, oh man, the input is empty, then yeah, go back to 20. And in fact, we can get rid of all this. And we'll say get k $. And then line 30 can actually just be this whole if statement, can be its whole own line. Okay, let's see the program now. So we're getting an input. We get an input over the wire, and then we get an input. What's it called? Sorry, we get an input over the wire, and we get a keyboard input. And if both of them are blank, then we loop, but otherwise we'll handle it. So we'll print whatever keyboard input we got to the screen, and we'll also, here, let's go over here on the same line, and I'm realizing I didn't show any of that. I'm sorry. Let me go over the program again. Close the user port, open the user port as a file. We get input from the user port and we get input from the keyboard. If both of those are blank, then we just keep getting information. But if one of those isn't blank, then we handle both of them. So we'll print whatever came over the wire onto the screen, and then we'll print whatever came into the keyboard over the wire. And I think I can do it like that. I can say print $1 with $K$, right? Commodore 64 print $. Print data to the current output device. Yeah. Current output device. Yeah, and I think we can print elsewhere, can't we? Yep. Print at emulation, print at move kernel's plot function. Ooh. Look into that later. I don't know what the hell plot is. Get print command that normally finishes returning. And I swear this will work. Let's just test it and see if it works. With sock. I want to just send all of the messages, and then we'll start a loop for yeah, I'll just say while true. Data equals sock dot receive, and look, just 1 byte. Or honestly, yeah, let's say 1024. We'll use a power of 2. That's a chunk. And okay, a blank chunk means means the connection was closed. Okay, but wait, I don't know the protocol, so we can't assume that. And let's just print the data. If it comes in fuzzy, or like messed up, then we can easily, what's it called? We can easily convert it, because like I mentioned before, COM64, all the text it's encoded in what's called PETSCII. So we gotta do some tweaks to make it readable. Syntax error in 40. Okay. All right. I think I can edit downloader. I think I print in this one. Do I? Print. Okay, syntax error in 40. How to print to a different device, Commodore 64. Seem to explain. Oops. How to print to a different device, Commodore 64. Open. Yep, it's open. Wait. Commodore 64 printers, so we have it open. Okay. Okay, so I have to add a comma there, much like the get statement. So that makes sense, actually. So we'll go up here, throw a comma after that, and then run it again. Okay, so maybe I can just. Okay, so what? It's ready to receive data. So I guess I can just start typing. Okay. Oh my god. Oh my god. Look at that. Look at that. Look at that. It printed it out. It printed it out. It printed it out. Okay, that's good. That's a great sign. Yeah, because the program exited because I never actually returned. Okay, great. Okay, after doing both of the prints, go to 20. Keep getting inputs. All right, run again. Hello, my name is Patrick. Oh my god. Oh my gosh. I lied. It's not Patrick. It's Go to Orangutan. I'm so sorry. Sorry to break the illusion. So, okay, it looks like it sends every character with the slash return after it. So, Ubar Baz. All right, let's stop. And sends 2 returns whenever it's done. So that's good to know. And here, we can also stop the program. Oh god. I don't know. Control Z. Oh man, I put it in the background. I suspended the program. I'm such a fool. Whatever. Um God, I have to kill a process. Oh god, I'm such a mess. And Vim. Kill it. Oh, it did something. Oh, I think I might have just been pressing on it on the keyboard or something like that. Ignore swap file. No. Stop. And Vim. I said sig kill, not sig suggest in Vim. Okay, so let's run control.py. Okay, so it's connecting. Once it gets the connection, it'll start typing stuff out. Okay, and it's receiving a bunch of nonsense. So all right, let's restart the program on the commodore 64, run, and then we'll run that again. Ring. Yep. Run. And it's receiving a bunch of nonsense. Or maybe, ooh, it received a byte for every single. I think it's okay. I think I can see one thing that's happening here is that after every single thing is sent to and from, it sends a new line as like an ACK. So it's saying like, "Hey, I'm able to read you, hearing you loud and clear." Okay. Let's change something. Let's say let's list, and on both of our prints, we should just add a semicolon to make sure that it doesn't print what's it called? A new lines at the end of the prints. Because I think that actually might be why it was doing that, doing the new line stuff. Because now if I type hello, goodbye, yep, okay, there's no more new lines. That's very useful. And let's see what this looks like. So these are all the. Let me zoom in a little. So this is what I'm outputting. I'm just like typing random stuff. Code orangutan, right? I'm just typing random stuff on the Commodore 64, and it's just out. It's sending them to my computer and running. And I also do want to test. So yeah, we can send hex codes across the wire for the various colors. I think this is a different set of, maybe that character. Yeah. Wow. Ba, 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 ba. Okay. And yeah, the run stop character is its own separate character. So okay, that's cool. Let's do some more editing. So okay, so we can get data to the Commodore 64. We can get data back from the Commodore 64. Let's make a data format. We're gonna send. Okay, let's do an explainer. Let's do an explainer. So the way it's operating right now, okay, the Python program is it's sending just like individual bytes, little bytes that go back and forth. You can send a byte, get a byte back, whatever. But wouldn't it be cool if we could send and receive a whole bunch of bytes? 256 or something like that, maybe even more. In my Discord notification, you probably heard that. That's my bad. I have a feeling it's from my boy, yeah. Yeah, so the way, what we want to do is we want to make a little format that the Commodore 64 can parse and that we can parse. Because like I said before, what if we have the issue of Yeah, what if our issue is, what if as we're sending this packet along, right? Because at the end of the day, the packet is still just a stream of bytes, right? There's still a bunch of little circles inside this green box. And let's make it maybe thicker stroke. Goodness, let me type text in you. Packet. We're sending packets back and forth, and at the end of the day, the packet is just a stream of bytes. What if it drops a packet, right? What if it does like wah? That's what we want to solve. That's the issue we're trying to fix. So we're gonna send a packet. We're gonna send packets over the wire. They're just gonna contain data, and they're gonna contain a way to verify the contents of the packet. So, okay, how do I calculate a checksum? I think I can just XOR them to calculate a checksum on arbitrary bytes. Simple sum. Yeah, sum. XOR, frequently used in simple serial communication protocols. Boom. Okay, that's what I thought. That's what my intuition was. We're going to XOR all the data as it goes across. So we're gonna start off. What's a packet made of? Let's expand this. Okay. And I'm making this up as I go, okay? I've done a little bit of thinking, but not much at all, guys. I've done a little thinking, I haven't done any research. Packet. Boom. Okay, so here's our packet. So the first byte. Man, I'm already Oh man. Okay. Okay, so here's the simplest way to do this. So the goal is to make sure that we're sending like the right data over the wire, right? And here, let me look at the Petsky table. Open Petsky. Here it is. What is character 0, I wonder? Hex 0. What is hashtag RRT? Okay, so yeah, I'm pretty sure 0 is safe for us to use. Yeah, it doesn't have any text, doesn't have any screen controls. Yep, okay, perfect. So, oh no, here we are. The first byte of our packet is going to be 0, which this just means, and here we'll do like, how big should our packets be? Oh, dude, I don't know. Okay, it's an 8-bit machine. 8 bits is 256. So let's say, rather like 8 bits, the highest number is 255. So let's say they're 256 bytes. So it'll send over a 00. This means start of packet. And what this means is that internally, what sending a start of packet means is that the Commodore 64 can start counting, and it'll know what's coming next. So start of packet is going to be the first byte, and then the second byte is going to be the checksum. Okay. So $01 is going to be the checksum, and it's going to be an XOR checksum. So what's a checksum do? All right, so a checksum it's basically like a hash. Okay, and here, let me reply to that Discord message real quick. I'll say I'm streaming. So a checksum is like a unique value generated based on the data, and really a checksum. Many checksums are hashes. They're bad hashes, but they're still hashes. A checksum, it allows us to check that the data is all in one piece. One piece mention. Let's go. So we'll send in a checksum, which we'll calculate on the computer's end. And then the computer will say, and actually, oh wait, no. Instead of, okay, all right, new idea. Okay, and here's what I just thought of. Okay, so we send the checksum, and this allows us to check the data if that all the data is sent over in one piece, that it all made it over. We can't verify that much of the correctness, but we can verify some correctness. But what we can say is once we receive a packet, so here the protocol, so we'll receive a packet of data, the commodore 64 will, and I changed my mind. That first byte, the first byte is going to be start of packet, right? Getting a 00 always means, hey, this is a new packet. Then the next byte is going to be the command. Okay, or like the 01, and that's going to be, yeah, it's going to be like the command or something along that lines. That's the type. And so the way that's going to work is we can have a couple kinds of commands, right? So if the checksum doesn't line up, then the command can be like, command maybe type, something like that. I don't know. I don't know, maybe even length. Yeah, for starters, we'll just say command. Okay. Command, checksum, and then finally length. We also want to know, because every cycle counts. So we have to make sure that, what's it called? If we can bail and stop reading early, then we should. But okay, so the command is going to be something like the command's going to be a couple things. So in the process, so let's say we're sending data over here. We're in our diagram. Okay. Are those lines connected? No. Can I connect them? Boop. Boop. Nope, can't be connected. Okay. We don't need them anymore. So if we'll send data over the wire. So if it's not true, the command is low-key optional, okay? If the command is 0, like the value 0, which I'll denote with like a number 0 is like data, right? We're just sending packets. Maybe 1 can be new packet please, or like resend. So if this checksum doesn't match or the length doesn't match, then we should ask for a resend. But if it does match, we want to let the other guy know. And we want to say like ACK slash success. Yeah, that'll do. And then the rest of the bytes are going to be just data. So that's the information we're sending over. So each packet can send 252 bytes of data, and it contains all this information. So it's got a 4-byte header and 256 bytes of data. And I don't know if this is good. I've never studied communication protocols. I've heard vaguely of some of these things, these concepts. I've never studied communication protocols. So let's just rip it and see. Keep seeing how far we get. Yeah. How long have I been streaming already? I don't know. Here, wait, let me go to my OBS window. Boop, boop, boop. Okay, it's already for an hour. Okay. All right. Okay. I'm thinking of how I'm gonna start this. And I think the plan is I want to write a program that, first off, on the Python side, I want to write a program that like parses a packet of data. And then I want to write a Commodore 64 program that sends a packet of data over. And I want to make sure that we can like talk back and forth with that. And this command here, I told you that we're going to save CPU cycles. So if we're doing a length, then we can start a counter, and it'll basically tell us like, hey, this is how much you need to be listening for. Otherwise, just don't. And then like once it reaches the end of the counter, it can be, the program can stop running, and it says, okay, my little buffer is full. I can process the information now. I can do stuff with it instead of just blindly receiving it. All right. Okay. Let's think. Okay. Okay. Yeah. All right. So first things first. Let's take it easy. Take it simple. So we have a function that establishes the connection. And actually, you know what? We're just gonna give ourselves like a nice cleaner slate. Let's copy. Well, first off, let's move control.py to like first prog send receive .py. Okay, and then let's copy first prog to protocol test.py. Okay. Protocol test.py. So we have a function that establishes a socket. Okay, we know that for a fact. We can connect a socket, we can read, and we can write from it. We can read from it and we can write to it. So I guess what we'll do is we'll start up, we'll establish the connection, and then I'll start a while loop while true. And eventually I'll change this to something else so I can like exit more gracefully or something, but for now this is good. So while true, the Python program is going to be the driver. Okay. Oh, and actually no. Let's add another command. Data resend ACK success, and number 3 is going to be ping. So this is going to be, we're sending a ping across, right? Like we're saying, hey, beep, boop. Like, are you there? Yep, I'm there. So that's how we're going to like establish, hey, is the connection live? And then the program is going to take control. either side should be able to send. No, let's keep it simple. Um, we're gonna send a ping first, and I want a class that's gonna make, what's it called? So class packet. All right, def init self self. And man, this is a real struggle. I wish I could. Oh, here, let me go to this scene. Um, right now, the way it like is on my the way I have my like setup is I have my like Commodore 64 keyboard basically in front of my laptop keyboard. It would be way more comfortable to type on the C64 keyboard instead of on this. But man, I think I might just have to force myself to struggle. um, whatever. Let's do it. So we're gonna start off with some basics. So the packet should have like what are the commands? So yeah, it's gonna be the command and the data. Okay, it'll calculate its own checksum. Okay, so we'll do self dot command equals command, self dot data equals data, and we'll add a little check here, and we'll say if the length of data is greater than, what did we say, 222, then raise exception. Too much data, bro. So that's how much data. And it'll also calculate the length. So yeah, we can say self dot length equals len of data, because that's part of our header, remember. Len or self dot length. Okay. Let's keep going. So we have our init function. We can make a packet. Let's make it so we can output it as bytes, as like PETSCII bytes. And eventually we want to be able to make a packet from PETSCII bytes so we can kind of interpret it inside the program. So, and here, let's actually document our like commands. We'll say like class commands, or I'll let you say command, and it'll extend enum. I don't know if I have to import enum. Let me look it up. Python enum. Okay. Yeah, I have to import from enum, import enum. Perfect. Things I should know, given I'm literally a professional Python programmer. From enum, import. Oh man, I'm so stupid. Import from. Oh man, I can't even type. From enum, import enum. Okay. Let's keep moving. Let's keep moving. From enum, import enum, and yeah, we have our enum here. And if I recall the syntax, it's going to be something like each field. So it'll be like data is the basic field. Then what is it? Resend is the next. Yeah, resend. No, wait, no, it's not. Resend is one. Is one. Ack is two. And oh yeah, ping. Ping is three and used for handshake. Question mark. I don't know. It's used for pinging too, but it's just I don't think handshake is the right word. I don't know what the right word would be. But okay. So all right, so we have that. And low key, it should be a command from the command. Python enums. Enum how to beautiful. Yep. Weekday 3 and it's weekday.wednesday. Boom. Perfect. So we have our packet. Yeah, and let's make it def 2 bytes self. So we'll start off with a buff. Is going to be b x00. Start off with a 0. Um, and then what? Low-key, this should be like a data class or something, but I could not be bothered, man. Yeah, okay, wait, to the buff, we add that, and protocol, and then the command. Oh, but how do I add the command as a byte? Sorry for popping my knuckles, but we'll do buff plus equals, can I just call byte on something? Byte on self dot command. Is byte a Python thing? Oh man, I don't know. Python from enum import enum, and then goodness, I'll say class dummy enum foo equals 1 bar equals 2 3, sure, why not? And then I'll say byte on dummy of 3. Byte is not defined. Did you mean bytes? Maybe I did mean bytes. What do I want? Bytes of dummy 3. Dummy 3? Yeah, it makes bar. Okay, how do I get the value from the enum? Print weekday.thursday. The repr shows the enum name and the value. Okay, how do I get the, okay, dot value. Okay, cool. Bytes dummy 3 dot value. Huh, it's three hex zeros. Dummy 1. That feels wrong. Dummy at 1. Dummy dot foo. Bytes dummy dot foo dot value. And it's a single. Okay, how to make a number into a byte in Python? How to make an int into a byte in Python. To fix size byte array. Perfect. Int dot 2 underscore bytes. Use the bytes constructor. Wrap it in a list. Okay, we're getting somewhere. Bytes list dummy dot foo dot value. So this gets the bytes from the list. X01. Perfect. That's what we want. Okay. Perfect. Protocol test.py. Yeah. And we'll eventually convert protocol to like protocol.py, and we'll write out the tests in a main function, and then we can just import our packet and our command into later programs. So, we're kind of building up a library as we go, and whenever we run the library files, they'll run the tests for the particular components in the files. If I write full-fledged tests, I doubt I will, but whatever. All right, yeah. Buff plus equals bytes, and we want just a list. self.command.value, and I guess it should be, and then buff plus equal bytes. And you know what? Boom, we're already constructing a list. Why bother constructing two lists? Self.length. Bam. Buff plus equals bytes out of our data. Self.data. Boom. Okay, so this should take a packet, convert it to bytes, and send it over the wire. So, all right, let's write a program on the commodore 64 that, and we can just modify this. Instead of printing the input over the wire, and look, let's rename I to W here on the commodore 64. W, if keyboard is blank and the wire is blank, then do nothing. Otherwise, print the wire. Oh, and I have to like press enter on all these lines, don't I? And print the wire, send the keyword over the wire. We look, you don't want to do this anymore, but that's fine. We'll print that, then a comma, and then what is it? Is it ASCII? W $? How do I get like the numeric value of a byte? How to get numeric value of string char Commodore 64? $, numerical values or variables into string. Yeah, ASC. Cool. Okay. So it should print it out and print the ASCII value. I think it'll be weird with our packet, but that's okay. Let's have our program make. Let's just have it ping forever. Yeah? Let's do it. It's going to start off by getting our low key, I guess, like state should be, I don't know how, oh god, I'm writing a web server using a socket as my connection, and I'm using the protocol to write the web server. Oh man, this is way above my head, guys. I don't this is not not infeasible, but man, what am I doing? It's gonna be a little state machine. Okay, we're gonna make another enum class, web server states, the subclass of an enum, and it's going to be handshake is 0. Let's start with let's be simple. So let's start simple. Web server states dot handshake. That's our starting state. While true, match. If state, we could use a match, but let's just be simple. If state is web server states dot handshake, then what we want to do is make a ping packet. Ping equals this, and low-key data is optional. The default should be like a tuple, like an empty tuple. Just like a little mutable thing. Okay. Ping equals packet with command.ping as our only command.ping and no data, right? That should do it. So it'll send ping. It'll make a packet called ping. And then it'll say, man, can I even do this operation with the buffer? Can I even do plus equals like that? Let's do another little test. B buff equals a byte string of hex 00. Print buff. Okay. Buff plus equals bytes from a list containing the number 1. Print buff. Okay, cool. So we can. Oh, wait. Buff plus equals bytes made up of a tuple. Wait, can I put a string in here? String in here? Hello. String argument without an encoding. Okay. Dot ASCII. Okay. Python bytes function. Python bytes function. All right. Range 0 to 255. Source encoding. Yeah, so we'll have to encode it as ASCII. Output ABC. Okay. Let's do, what is it? Is it a keyword argument? Quarg encoding. Okay, yeah, it's just a position argument. ASCII. Will this encode it? Print the buffer. Okay, I think that's what we want. And that does reveal to us that we need to change our class, because I want to be able to just pass it strings. I want to be able to pass it any kind of iterable data type. And you know what? Let's do one more Python test. Bytes made up of a tuple 1, 2, 3. Yeah, okay, that works. All right, yeah. Protocol test. Okay. So command in length, if self.data, if is instance self.data string. If it's a stir, then yeah, self.data just is self.data. No, it needs to be bytes. It needs to be bytes. Bytes, data encoded as ASCII. And then otherwise, self.data is going to be bytes of the data. If there's an exception, so be it. That's just how it's got to be. I know. I deleted that. Yeah. Okay, so our ping packet Okay, wait. If length of the buffer is less than 256, then I guess it's fine, actually. Yeah, then I guess it actually doesn't matter. Um Here, return buff. And while I'm at it, do one more test. Python bytes on oh bytes of oh yeah, an empty set. That's what an empty tuple I wanted. Bytes on an empty tuple. Empty. Okay, cool. I thought this was valid syntax. Is it not? Do I have to manually specify tuple? Is this not even gonna run? Oh man. Oh, look what they did to my program, man. Okay, so we make it if the state's handshake, then we make a ping packet. Sock.send ping dot 2 bytes. And we'll just wait. And low-key return. Not even wait. Oh, we gotta do with sock. We gotta do with sock. So while true with sock, and then I'll just manually tab it. Python protocol test. And let's make sure we're running our listener program. Okay, it got a ring. Okay. Connected. Boom. Packet has no attribute data. Ugh. It's because I'm a fool. Self.data. All right, go again. That was fast. I guess I don't even know if I need to wait a second before, sending stuff. But there is the number 3 on screen. It looks like the header on the Commodore 64, it's always getting a 13-0. So where is that 13-0 coming from? Here, Loki, let's say def repr self return a string that's packet what's it self dot command self dot data, boom. And then I'll say def, it doesn't need 2 spaces, def stir self return packet, whatever. I'm not making a string function right now. print ping, because I think maybe, I don't know if it's socket library sending. Oh, it's not an F string. Self.data. Okay. 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 F string, and then we want to make it so that it actually prints out a string containing our stuff, not just, some random bullcrap. Okay, so ring 1310 connect 300, 1310 3 blank. Why is it printing blank lines, I wonder? And then it disconnects, no carrier. List 40. Man, what is this 1310 stuff going on? Because the bytes it creates. Yeah, wait, I wonder. Here, 14J. Send, isn't it like send all or something? Maybe that's the issue. 300, 1310, no carrier, 1310. Every message is preceded with 1310 for some reason. Okay. Let's keep going. Man, this is gonna take a long time. This is gonna be a long project. This is gonna be like a bunch of streams. This project is. Loki, I might just like stream for a while. So I might go till like midnight or so. I'll stop at 11:30, even though I should. Or no, yeah, I'll go for a minute. I'll go till I'm done on whatever nights. And Loki, I might even stream tomorrow night. I may stream. I'll stream on the weekend for sure. Just I want to get this project done. I'm excited about it, and I think I can see the light at the end of the tunnel already. Yeah, and Loki, I also want to print ping.2 bytes. I don't know, yeah, because I don't know where 00300, and it's interpreting that somehow as 1310 300. Well, do we need a different like sentinel character? Because I guess if it's a state machine under the hood, then the initial packet command like doesn't really matter that much, right? It doesn't have to be 00. I don't know. I'll keep banging my head against this. Um, okay. Invent protocol test. Right now, it's printing out the character code, the character and the character code for every single thing it's sending. So yeah. All right. Once you finish that, break out of the loop, and then sock.send a byte string containing A B C D E F G, or send all. What's sock.send versus sock.send all? Python sock.send versus send all. Send is a low-level method of C/syscall. It can send less bytes than you requested, but returns the number of bytes sent. Interesting. Sock.sendall is a high-level Python-only method that sends the entire buffer you pass or throws an exception. It does that by calling socket.send until everything has been sent out or an error occurs. Okay. Send all. Okay, yeah. We should be using send all. Yeah. All right. Run. So it'll say ring connected. Okay. So this is an encoding error, I believe. Or it's it's the fact that we sent lowercase. Interesting. Okay. Okay, yeah, we can work with this. A B C D. What is it? Dot upper? Is that the Python function? And having IntelliSense is really pushing my pushing my noggin to what's it called? Have to remember all the stuffs. Connected 300, A B C D E F G. Yeah. Okay, so it's not receiving 0 bytes. It's not receiving zeros. And honestly, wait. I'm wondering if it's treating man, if it's treating the blank as, you know, here, stop the program list. Is it treating blank as 0? Because if it's equal to blank, then 20. Here, let's go to the Petsky table again. Let me look at it. Let me study the Petsky table. Let's look. Man, what is Control A? Um, I don't think that did anything. Control B. Control C. Run. Control C. Okay, well, it entered something. Okay. Well, hmm. Let's, I guess, Google. What does Control A do? Or wait, should it really be? I think if I do Shift this and then I do Control A, Control A, yeah. I guess it does nothing because I'm able to type Control A. You can see it in the symbolic entering, but it's not doing anything. So, okay. Instead of 0, let's try sending 01. So, okay, let's update our documentation. Start of packet. And it's going to be 01. Okay, so, and I guess actually this needs to be updated to be 1. Or man, do we even need the start of packet thing? I don't know. Suppose we don't. Here's what we could say. Reserved. Right? Or maybe version. It's version 1. uh, sure. Why not, man? That'll do. That'll do. Okay, so let's give an overview of what the packet's made up of. So the first byte is the start of packet, which it just says the version of the protocol. Okay. Then next it sends a command byte, which contains, whatever the command is. Then it will send over a checksum byte of the data. It'll also send over the length of the data because it can be shorter or it can be all 252 available bytes. Because we have 4 bytes as the header, 256 minus 4, 252. So that's how our packets work. So let's change that. Yep. Okay. So data is going to be 1, 2, 3, 4, and we'll say da, 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 da. Too much data, bro. Yep. Packet start. Or Loki, we'll just say version equals BX01. And we can subclass it and we can change the version. Self.version. Is that a valid way to do things? I think I can do that. Yeah, okay. Run. Make sure it'll print stuff. I think it did. Wait, let's get rid of the ABCDEFG. And by the way, yeah, it did print out the ABCDEFG correctly. Boom. Okay. Okay, moment of truth here. No carrier. 13101400. And that's actually fine. The data, the 00 is what? That's the length. Why can't I send a 0 over the wire? Is the strange part. Hmm. That's weird. I don't know. That feels problematic, is all I'm saying. Hmm. I don't know. Can't send x 00 to send all Python. Yeah, wait, is it a send all issue? Correct way to send a null byte or bytes from hex. Send all data. Correct sending it with other data. Message. Is a byte string, not an integer. Yep, okay. Null terminated. Never use C-string handling. Okay, debugging might print a string or nothing at all. High serial. I'll look into that later. Because okay, every packet should be at minimum for 4 bytes, right? Actually, sure. I'll say header self.version header plus equals that, and then we'll go and calculate the checksum. Checksum will start off at 0, and then 4 byte in self.data. Checksum XOR equals byte. And then header plus equals self dot checksum. So I'm wondering if it like can't be the last character. We'll see. We'll see. This will be the test because the length is 0 and the checksum is 0. And then it'll return the buffer. Okay. Run monkey. Ring. Okay, and then connect 300. 1310. Man, what on earth is 1310? Oh, that's the that's the saying. That's the hey, communication. I feel like I wasn't getting that before, guys. Was I? You know, I was printing, but I wasn't printing ASCII value, so I probably was getting it before, to be honest. Um, and it's not self.checksum, it is just checksum. Buff is not defined. Oh man, screw off. Buff, return header plus self.data. Concat those two and send them over. Oh my gosh, I'm such a fool. Return DW. Right quick. Moment of truth. Okay, let's do a communication protocol. 1310 1014 no 0. Man. 1310 1400. That is awfully vexing, isn't it? Okay. Where did I ask that question? Can't send x00 with sending 00 to server in Python. Edit new lines and die are stupid. Trying to pwn a CTF. Hmm. Hmm. Okay. RIP EIP. What is that? Oh, these are registers. Okay. Um, how to Commodore 64 can't receive 0 byte over Python socket. Commodore 64 can't receive like B um X slash X00 byte from Python socket. Is it treating it as a string terminator? Hmm. How does the I think this might come down to like how the modem works. Like, do I perhaps have to like man, what is 255? What character is 255? Because I might just have to bump everything up and then subtract one from every single character. Yeah, what's FF? Looks like it's nothing. Pi? Tilde? Oh, it's something. That's tricky. Oh man. So it's sending one, and then it's sending a four, and then it's sending null and null. Um, here's an experiment. What's the ASCII of an empty string? Syntax error. Um, ASCII. Hello. ASC H. Am I on? Yeah. Okay, I'm on screen. Syntax error. Like what? F $ equals equals H. Okay. ASC F $. Syntax error. List. What? It's working. Is it just a basic command? What if I say 60 ASC boom? Oh, it needs to be like print ASC boom and go to 60. Illegal quantity error in 60. Interesting. Um 60 print ASC foo. Go to 60. 70. Is it just the first character? I bet it's only the first character. Yeah, wait, what's Petsky? Yeah, ABCDEF. Yeah, that sounds right. Yeah, F. Oh, C6, 198. Oh, it's 70 over here. Hmm. It's not what I expected, but nevertheless. So 0, 0. Man, oh man. 80. And then it loops back around. Okay, 0, 0 in this case. Then it should be the @ sign. And also, why is it sending 13 tens? What is 13? $13 on this column. You anywhere? $13. 13 should be lowercase s. SP? Socket put? Maybe? I don't know, dude. Oh man. Okay. Well, all right, our protocol's not going so well. But it looks like it only goes up to 1F maybe? No, then it's got a bunch of other stuff up here. It uses FF. Can I even enter a tilde? I don't know how to enter the tilde, man, because I don't have a keyboard with the right keys. We're with like key labels for the Commodore 64. It's in fact I have blank keycaps. I'm wondering. Okay, this is the duplicate. Oh, brother. What if there's something afterwards? What if we give it some data? Okay, and we say uh data equals b hello, or just say hi. Will it still send the data? That's the question. Oh. Okay, it sent 1 4 2 1 hi. What's or it should be two characters that cancel out, so the checksum becomes 0. So hi. Just two of the same character. AA. Not gonna catch me typing HH, brother. You are not gonna catch me typing HH. That is for sure. Ring connect 3 1310 1 4 2 65 65. Interesting. Okay, it's not catching 0 bytes over the wire, and I don't know if it's an issue sending it. Can Python sock send a 00 byte? Yes, it can send the null byte. Yep, okay, that's what I did. Encoding errors. Hmm. Okay. Um Commodore 64 can't receive null byte. Delimiters for the ends of strings and the end of basic lines. Serial data transfer. Okay. Can't receive null byte from serial port. Rather than a hardware limitation. Okay, so it can. Or treat a null byte as a lack of data. I bet that's what's happening, man. Use assembly to read the receive buffer. And you know what? I'm using. It says use UP9600. So, all right. What if we rerun? What if we need this thing? 1310 82 7378 71 1310 142 6565. Okay. Mr. Hmm. Mr. UART modem not receiving null byte. Mr. MIDI link. UART not receiving Null hex bytes on this. Oh, I don't know. This is not relevant to me. Okay. L, or shoot. GeoRAM, RU, external IEC. Yep, okay. UART mode, it's set to modem. Link is TCP, UDP, TCP. Exit. Man, what is the issue here? Here, what's the assembly routine for get hash in basic Commodore 64? Kernel routine. Call get input. In terms, it can't read. RS-232 serial limitations. Okay, let's look at what these are. And you know, I don't want to throw in the towel, but maybe, just maybe, it might be prudent to use what's it called? Pressing any of the keys will send the letter in ASCII. Finally hitting enter will transmit the byte. Yeah, it might be prudent to see if there's an existing communication protocol. Hardware disabled. UPN 600 connection mode internal real-time clock. Yep. Clear RAM on reset. Reset run in pure G. Tape autoplay. System ROM. Boot cartridge. None of that. None of that. Okay. What is happening? Well, the issue is that it's not receiving the byte 0. And it's getting this weird. It's like printing 1310s a bunch. Commodore 64 printing 1310 character when get from RS-232 UART modem. Serial communications. It wants me to open it this way. 120. Man, figuring out Commodore 64 is RS-232. Yeah, see, this guy's not connected to like a breadboard and he's doing stuff. User port 4. Can't receive 0x00 byte. Commodore 64. Maybe someone's experienced this before. End of basic Sentinel. Serial limitations. RS-232. RS-232. Often interpret 0x00 as a string terminator. Okay. How to read kernel, how to read user port Commodore 64 without get. Oops. Directly access the complex interface adapter. Okay, so let's implement that. Let's implement that real quick. Okay, let's give myself some more lines. I'll say like like 90, 80, 70, 60. And we'll say 20 is just going to be get K $ from the keyboard. And then line 30 will be poke 56579 to 0. I don't know what this program does. Whatever, we'll run it. What's the worst that can happen? 40, we'll say value equals peak 56577. We'll read all the pin states. Rem read pins. And on 50, we're going to print port value v go to man, I guess 40 to read until eternity list. Yeah, okay, let's just run that. Port value is 239. Okay, so let's send it some data and see if it changes. 239. Now, it usually would have printed a ring at some point. Oh, it printed something. Okay. I'm gonna use AI for this part. How to read security system user port. Okay, let's read this article. The IC is accessed via peek and poke commands. Lines 0 to 7 are the parallel port. Ground. Data 0, data 1, data 2. Program the user port with no sources. Okay. Let's think. It's 239. So I don't know what that means. Actually, I want to input to port mode. So it's all 8 pins as inputs. CJ's project blog. So to say straightforward. The chip controlling the parallel port is a 6526 complex interface adapter. The other chips is control by a series registers. Make all lines outputs. And line 40 turns the individual lines on and off. The register is 8 bits wide. Each bit is connected to one of the output pins. 255 would turn on every line. 0 would turn them all off. If we send the number 0 to 255, the LEDs will turn on. Okay. Okay, so that's something. So what does our program do? So 56579, none of them are on for output. It pokes all this guy pokes all the values in, gives a pause, and then keeps going. But I'm peaking on 56577. So I guess like, man, I don't know, dude. I do not know. what is chur in? Commodore 64 chur in. Kernel ROM making sense. Kernel modules. IO. Read status byte. Initialize. CA. Read input. Read byte from input channel. I think maybe we want chur in. Okay. Yeah, wait, this is promising. Instead of get. Commodore 64 chur in versus get. Churn and get. Go over there. Go over here. Okay. And okay, I'll move my tab over here so y'all can see. Get in reads a single byte from the default input. It reads a byte from the current logical file. Okay, so it's open as a file, man. Guys, I'm stumped. Call me stumped. Maybe okay, let me clear these lines. 30, 40, 50. And then line 20 should be get wire $, or get #1 wire $, get K $. Now we should be able to run. And we should be able to run that. And it's so odd. I've confirmed it's sending 1310 before every communication. Or maybe is the Commodore 64, how does Mr. Commodore 64 modem work? Virtualized modem, hardware emulation, UART redirection, network tunneling, baud rates. UART, connection internal, hardware mode. CCGMS. C64 modem connection. Speed is buffer lagging. Programming BBS software. Same thing with 2400. I've not tried up 9600. Not related to baud rate. Okay, it looks like there's some issues with it. I don't understand the 1310 thing. And I also don't understand why it's not letting me send 0, dude. Like, what the heck? Mr. Devel. MIDI link Mr. Devel. Hardware Mr. Main Mr. Oh, I'm never gonna find that. I'm gonna break. I'm gonna look on Gemini. I'm gonna ask Gemini. Have a program that, here, let me list the program that does open 120 chur $7 on the Commodore 64 and reads from it. Commodore 64, Mr. UP 9600, 1200 baud. When I connect via a socket, it can't receive the null 0 byte. I can send any other characters connect via a Python socket. It can't receive other characters. I know my prompting is bad or whatever, but this is just better Google, I guess. Defining the problem. When I click on Python, I can't receive a null byte. I can send any other characters. Yep. Kernel issues. Man, am I on the right kernel just to check? Oh, that'd be so crazy if I wasn't this whole time. UBRT mode. Let's check. It's hardware, isn't it? Standard G64. Okay. Exit. All right. While that's loading, I'm low-key gonna go pee. I'll be right back. All right, I'm back. Let's see what Gemini has to say. The C64 get hash bug. Reading incoming data. And it's an empty string in two completely different scenarios. Literal null byte or buffer empty or null byte. The fix, get. By peeking this address, you can determine if the byte is actually waiting. Okay, so this is promising. List. So let's do it on line like 15. If peak 649 equals peak 649 equals 0. So what we're doing is we're peaking directly in the receive buffer. So if it equals 0, then go to 20, and then on line 20, we'll say get over the wire if the wire character is nothing, then char equals 0. And then go to, I guess, line 30. On line 25, we'll say char or low-key C $. C equals ASCII of whatever came through the wire. And let's go back here and C equals 0 and go to 30. List. So we're opening the file, peeking at the character length buffer. peek at the character buffer, then go to line 20. Oh. It should be line 15. Peek at the character buffer, and if it's empty, then keep looking. If it's not empty, then we can get. And if it's blank, then that means it's 0, and go to line 30. But otherwise, we have our C, and we can actually get rid of this. So this is just for the keyboard check. And then now we can print W, and we don't even have to ASC W anymore. We can print C. All right, undef statement list. Then char equals 0, run. Undef statement error in 20. Get #1 in W $. If W $, is blank, then it might be this spacing issue or something. Or is it char? Yeah, I think it might be char because we said it was C. Run. List. Okay. Then C equals 0. 20. Okay, let's constitute the line from each principal. Run. Illegal quantity error. Okay, cool. So it received a blank string. 20. So interesting. It has bytes in the read buffer. Oh wait, is it 1200 or 600 baud? I forget. 600. Okay, yeah, I was right. Okay. Let's get this fixed. So 20 get $. If W $, equals blank, then 20. Run. Okay. That's good. If then assign something, then C equals 0. Run. Illegal quantity error in 25. That's because it didn't make it out. And T equals 0. Otherwise, C equals 0, and then go to line 60. Skip it. Oh my gosh, the undef statement. I think the undef statement was I did go to 30, and there is no line 30 yet. Okay, so it printed run, a ring, 1310, 82, 73, 78. All right, no zeros still. How odd. Okay. Being printed. Because, man, I want to be able to do this. You know what I'm saying? Because like it'll start off listening, and then if it receives the packet start, just the version string, the version byte, then it'll read the header, and then it'll read the next length bytes. Man, I'm loath to use ChatGPT to debug this issue, but I'm really at a loss. I'm at the point where I might have to ask, like, the C64 Discord or like the Mr. Forums probably. Okay. Mm. Okay, let's write this little diagnostic program it wants me to write. Let's do it in like line 100. I don't think 100 is taken, is it? Yeah, okay. 100 if peak 649 equals 0, then 100. 110 get hash 1 a $. 120 if a $, equals blank, then v equals 0, go to 140, 60, or 130, and oh, I haven't been showing this. Apologies. 130 is just going to be set the value to the ASCII of the $8, and then 140 is print v space, and then 150 go to 100, go to 100. File not open, error in 110. Well, 11 go to 100, run. So it's got zeros on deck. When I run the program after opening the file, it's printing non-stop zeros. Okay. There's actually not serial communication. Breaking 100. List. Okay, so it's actually going to be if peak 667 is equal to peak 668. So okay, so it sorts like the tail of the incoming data in 667 and the head in 668. So when they're equivalent to each other, the buffer's empty, but when they're different, it means we've started to receive data. Then, so if they're the same, then go to 100. All right, run it. Okay, so it's not printing anything. Let's do some Python. So it printed nothing. Maybe it'll print ring here in a second. Okay, nothing. So now it's printing nothing when I send bytes over. I don't think Gemini is going to be able to fix this. Maybe Claude could or something like that. I don't know. I don't really care to, step through a billion hoops to like ask all the AI LLMs to figure out, X from Y from Z. Yep. Okay, it's running. It's opening, closing it, opening it. I'm going to line 100. If they're not equal, so if they're equal, then just keep reading. If they're not equal, go to 60. Get the character. And yeah, no. No. The Mr. was able to send data. I can do a sock that send B, BCD, and it receives it just fine. Stop. And receive it just fine. ChatGPT or Gemini, it's your diagnostic that's broken. Ugh. Okay, let's keep trucking. I've already streamed for 2 hours, so I can stop whenever I want. But man, I want this to work. Okay. The state of things. I'm able to send data to and from. I have a communication protocol sort of laid out. Stop using get hash entirely. Okay, so let's list. Okay, so we'll start off at 100 or 110. We'll set to close 1, open 1 to 0, sure, $7. 120, rem, blah, nulled, sure, 130. H equals peak 668, and I don't think this will work, but I'm just going to try it. The worst that can happen is I run a failed program, and I do more off-cam, offline research. 50 rem. If they match, hit empty. 160. Oops, 160. If H equals T, then go to line 30. Then keep, 130. 70. Rem, calculate, buff. 180. BA equals peak 248 times 256. Oops, plus peak 247. So that's high byte, low byte, by the way. 90 rem, read the raw byte directly. 200. V equals peak BA plus H, 210 rem advance head pointer until end alert. 220 will be, what's it called? 220 H equals H plus 1. And then if H is greater, oh man, where's the greater than sign? Oh, that's where it is. I'm a fool. It's greater than 255. Then H equals 0. Man, sorry. The keyword mapping on the Commodore 64 is not the same as a normal computer, rather as a QWERTY keyword. And man, I can never find I the equal sign and the quote are in the wrong places. So in my head, I'm like thinking that it's a completely different map. So I always second guess myself when typing symbols in. Okay, line 230. We're poking 668 with H. So yeah, we're updating the head pointer. In 240, we are rem print integer value. So here's where we'll get my screen output. 250. Print V semicolon and then a space and a semicolon. And 260, go to 160. Or, sorry, 130. And then go to 110. All right, so we have our program running. Now, let's see if this is a good bare metal routine for, reading data. So I would be expecting output here already if we were using get hash, but it's not working. Instead, I get no output at all. Close the file, open it, peek the head and the tail, calculate the buffer position. The head tail thing doesn't work. Man. How confusing. Man. Anyways, so I was working on another project. So there's this little console called the Pokemon Mini. Let me pull up a photo. Let's go to the explain. Pokemon Mini. While that crunches. Pokemon Mini. So this is a little tiny console. It's the smallest. What's it called? Yeah, it's the smallest cartridge-based console in the world. Anyways, I'm like somewhat involved in like the dev community for this console now. The compiler for it is really old and it only runs on x86. Um, let's extend the bridge. The underlying daemon handling that is certainly an operating as a telnet server. Understanding telnet protocol rules. Null is a no-op padding character. Actively drops it. Stop sending null bytes. Never touches the wire. Here are the best ways. Simply offset your values. Yeah, I think it's got to be. Yeah, I had that idea where we would, you know, I just don't think it's going to be able to send 0 bytes, quite frankly. I had the idea to basically just add 1 to every byte. So it'll be this. Return bytes made up of byte plus 1 for byte in header dot whatever bang bang. So now it'll send to the version header plus 1. And in fact, here, let's list our program. And it's got a bunch of crap in the end. 100. You know what? Let's just do new because I think I remember the program. It's open 120 chur $7. Okay, new 10 close 1 open 120 chur $7. That's the right baud rate. And then I'll say get from file 1, get a character from file 1 called W W string, and then W string, and then if W string equals nothing, then keep reading. But if it's not, if it's something, then I'll say W normal equals ASCII W $-1. And then I'll say on line 40, print chur $, space W, no space, and then another space, and then no new line character. And then line 50, go to 20, keep reading, and run. Okay. Type mismatch in error in 40. Print CHR. ASC, is it CHR $? Okay. List print CHR $, run. Now we want to go print again. Oh God. So that's wrong. All right. Oops, sorry. Okay. Maybe I want new lines again. Oh, list. Oh, it printed some gunk to the screen. List. All right. So it'll print whatever character W is, and then it'll print goodness, it'll print W itself. Run. Okay. QR. Oh man. Oh man, oh man. All right. List. Okay. So we clearly are calculating something incorrectly. Because the command ping is indeed calculating correctly. Let's just go back to the what's it called? The Petsky codes. Sure, $. How to convert byte to char. Maybe it's like here. Commodore 64. Sure, $, sets it to A. So you know what? Here, let's just instead of printing the character, let's just clear all that. Let's just print just the number and a space. Print number space with nothing. Run. Okay. So now we're listening. Protocol test. So it should, after it says the connection 300 thing, I should see the sequence 1 4 2 0 6 5 6 5, and oh my gosh, it's right there in the middle. I wish I had like a laser pointer that I could like do on my OBS thing. But yeah, it's right there in the middle. Boom. Boom. Oh my gosh, that's amazing. Okay. Well, hey, I think we're gonna stop it there. We got packets. We got packets sending to the Commodore 64. I have the communication protocol written out. I know how to open and read files. And you know, let me quickly scribble this program into the protocol test.py. Gem protocol test.py. All right. Let's put it in like a doc string, like I don't know. Here. 10 close 1 open 1 2 0 sure $7 20 get #1 W $, B $, if W $, equals nothing, then loop forever, else W equals find the ASCII value of whatever we just got in and subtract 1 from our offset, and we'll print W with a space, 50, read, go through 20, keep reading. Boom, bam, done and dusted. Okay. Okay, I think that's good, guys. I think we did it. Invent protocol test.py. Let's go to the repr. 2 bytes, and I'll say, or low key, let's just do, let's like print the string, def string self, and it should be return str from bytes. And guys, I don't know if this is efficient or not. I know it'll work though. That's the beauty of Python. B -1 will de-offset for B in self dot 2 bytes. Okay. And I just want to check and make sure it's printing correctly. Yep. Okay. 04 010402. Oh man, I just could not be happier. Wow. Wow, wow, wow. Okay. Well, we've invented a communication protocol. I think that's what you would call it. I don't know technically. Yeah. Wow. Stir ping dot 2 bytes. When did the repr get called? I thought that's what that was, man. Wait. Does Python print call repr? It does not call repr by default. If stir exists, it uses. Huh. Okay. Well, cool. Good to know. I learn something new every day. Yeah. You know what? That's low-key fine to leave as is. But yeah. All right, guys. I think that's good. I think I'm done. I think I'm happy with where we've gotten for today. I'm stoked. That should be great. That should be great. All right, guys. Thanks for watching this VOD if you are. Otherwise, I'm gonna go to bed. Have a good night.